talked about them a little bit, but we're trying to find the maximum value of a function. So the story I always tell, a girl I went to uni with, she got a job. She was really good at the coding side of mathematics. So at uni, she did like a lot of coding stuff. And she got a job for a company where they are like analysts. So if you run a business, you call out these people and like, where can we like do better? How can we make things better? She was telling me about she got called out to a fish farm and they're like, can you look at our data and give us a model based on how much we should feed the fish so we get maximum growth? Because if you overfeed the fish, it's actually bad for them. And if you underfeed them, they don't grow as fast. So they got them out and they like made all these mathematical models and they found the maximum, theoretically, that if they feed them this amount of food, the fish will get this, this big consistently, and that'll make the most money for you. So this is stuff that is used every day. So the way they do that is they look for stationary or turning points of functions. Oh, that's the wrong color. Why would we call them stationary? Does anyone know? Well, they are. Because if we look here, my graph is moving the entire time because this is my... Yeah, but this would be my stationary point. Why would I say it's stationary? Yeah, you're on the right track. So, because that's the point where the derivative is zero. The derivative, there's no rate of change. It's stationary in terms of it's not changing at that one point. So a turning point in a function gives critical information. For example, if you're modeling the average grade for a question in an exam based on length of responses, and you notice a turning point at 150 words, it would make sense to limit your response to 150 words. So if you find that the best marks correlated with 150 words, that's what you'd be aiming to write. Okay, so this shows a ball that was kicked into the air. So at what point does the ball have a stationary point where it's not going up or down? Well, it has a stationary point at x equals 2. So can you see that the derivative there is flat, 0? There's no upwards movement, there's no downwards movement or change. Before the turning point, is the function going up or down? Up. The entire half before that is going up, after it going down. And that's it. Okay, this one's a little bit swankier. One at a time. So the blue is my function. The red line is the derivative. So what I want you to do is look at the blue line and where it has turning points. And I want you to tell me what the derivative is doing at those same points. So where my blue function has a turning point here, what's the derivative doing at the same point? What is the value of the derivative at that point? 0. What about here, where I have another turning point on my function? What's the derivative?
0 again?
That's next door. 0 again. What about where the third turning point I have is? What's the derivative doing at that exact same point? It's equal to 0. Guess what it's going to be in the next graph? At this first turning point here, this minimum point, what's the derivative doing? Next one, 0. Last one. So describe the relationship between the original function and the derivative function when the original function has a turning point. Whenever f of x has a turning point, f dash of x equals 0. So that seems a bit dumb, but it actually is quite helpful and quite important. Every time the original function has a turning point, the derivative is 0. So if you want to know where a maximum of your function is, you don't need to graph it. You can just find the derivative and find when the derivative is equal to 0 and find it that way. which for some functions like x cubed minus 18x squared plus 35.276x minus 10, you wouldn't want to graph that. But you can differentiate it and solve for zero quite easily. Okay, questions on that one, guys? I love having 6 students. There's no questions. We'll get through this in no time. Okay. In every function that can possibly exist, the derivative function will have zero value wherever there is a turning point in the original function. So this is true for every derivative everywhere. Every single one. So to find the stationary points of a function, differentiate it, set the derivative function to 0. So I've got this function here, y equals 3x squared plus 2x minus 6. How can I find where its turning points are? Need to find 0 equals to what? 0 equals to 0.
3x squared plus 6.
Nope. What is it that equal? If we go back up, what was equaling 0? The derivative. So I need to make y dash equal to 0 to find the turning point. So the derivative has to be 0. So I'm just going to make a note to myself. Find y dash and set to 0. So y dash, guys, if I'm 6x plus 2. Happy with that? Okay. And then, because I want to find where the turning point is, and I happen to know that the turning point happens when the derivative is equal to 0, I'm just going to make that derivative equal to 0. So 0, 0 equals 6x plus 2 minus 2 from both sides. Minus 2 equals 6x. Excuse me, guys. And then just divide both sides by 6. And that... Miss Neil. I'm a sad man, you know. Well, you're just describing my everyday. Negative 2 over 6, which would be negative a third. I'm fine leaving it as a fraction. So equals negative 1/3. So it has asked me to calculate the stationary point or points of the function. How many answers did we get? 1. Sometimes there can be 2, sometimes there can be more than 2. But for this one, there was only 1. If we ever do, well, we will do trigonometry. And when you differentiate sine cos, they give you a sine or cos. So you can see for this one, it would technically have infinite peaks and infinite maxes and mins. So there can be a lot of answers. But we need to solve it for negative a third. So have we fully answered the question? I guess. Yeah. Have we calculated the point, the stationary point? We've calculated the x value, but we don't know what the y value of the stationary point is. So to find the y value of the stationary point, what would I do with my x equals negative a third? Yeah, put it back into the original equation. So to find stationary point sub x equals negative 1/3 into y equals 3x squared plus 2x minus 6. So that gives us y equals 3 bracket squared plus 2 bracket minus 6. Negative 1/3, negative 1/3. Equals negative 1/3 squared is positive 1/9. Times by 3 is positive 1/3. I'll do that as 2 steps. Three times a ninth is 3/9 or 1/3. Plus 2/3. Sorry, that's minus 2/3, isn't it? It's minus 6. 1/3 minus 2/3. What's that? 1/3. Negative 1/3, and then minus away 6. Well, that would be minus 6 and 1/3, or minus 19 on 3, if you wanted to do it like that. So when I say minus 19 on 3, so we're almost done. So therefore, there is a turning point at negative 1/3, comma, 19, negative 19 thirds. Notice, guys, I have alternated between using stationary points up there and turning points down here. Am I allowed to do that? Yeah, they mean the same thing. So 1/9. Yeah, stationary points and turning points are the same thing, so you can use them interchangeably. I would suggest if you're doing one question, just choose one and stick with it. I'm probably being a bit too erratic there, but whatevs. Questions, comments, concerns, quizzes, quests. Is anyone on a quest? Not today. Taking a rest from questing. Crusades. Is anyone on a crusade? It's kind of a quest, but just like meaner. Okay, we good to go on? Yep. Okay. Evaluate the stationary points of this function now. So we will do the same thing. Now for this one, guys, I actually prefer for these questions not to use y. I prefer to use f of x. Can anyone guess why I might prefer to use f of x for these ones? Yeah, basically, because you're going to be subbing in like x values and stuff, and rather than saying like, I'll rub this out a second, but instead of saying like, find when y dash equals 0, it's easier to say solve f dash of x equals 0. I prefer the right hand working out myself. But if you want to use y dash, you can. I just find it's a little bit more wordy. So I prefer this way. So we're going to solve for f dash of x equals 0. So f of x equals 2x cubed plus 4x squared minus x plus 3. So that means the derivative of that one is 6x plus 8, or 6x squared plus 8x minus 1. And then the 3 disappears. So what would we do now? Uh-huh. 0 equals 6x squared plus 8x minus 1. Well, this is a doozy. Last one we could just algebraically rearrange, but this one, can we just like move x to one side? Is that going to work? No. Yeah, because there's an x squared and an x. So what type of equation is that if it's got an x squared and an x and a constant? Quadratic. That quadratic there, is that going to be easy to factorize and answer out? No, because it's non-monic. It's got a 6 in front of the x squared. So what are we going to have to do to solve that quadratic? Assuming this is tech-free. That's not going to work.
6x plus 8. 1 equals.
1 equals 6x squared plus 8x. But then to get rid of the x in front, you'd have to divide it through both sides, which would give you 1 over x equals x, 6x plus 8, which would be even harder to solve. If you ever have this, guys, where it's a non-monic and it's tech-free, there's only one way to solve it, really, reliably, and that's quadratic formula. So we're going to have to do quadratic formula. Well, I can't see a way around it. It's like if you're driving somewhere and the road's flooded, just got to floor it. Like there's no other choice.
What?
I'm not. I well, like I'm not gonna stay in my car as it slowly fills up with water, am I? Well, if it's filling in, you would be able to because it'd be pressurized from both sides. Um, I saw it. This is, I'm just gonna pause it. Anyway, quadratic formula. Yes, I had them come in Tuesday. I'm not 100% sure what they're doing specifically, but they're here like visiting and just seeing what other places in the world are doing. Um, X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Yeah, it's quite fun. Like, Americans have a weird way about them where like I think they forget that the rest of the world doesn't necessarily care about America as much as they do. Like they were introducing themselves like, "Hi, I'm Cindy. I'm from Ohio." It's like, cool, bro, cool. Oh, like they came in and it was just really awkward. I was like, "Oh, would you guys like to introduce yourselves?" Because like I just like walked in the middle of my lesson and they're just like, "Hi, I'm Cindy. I'm from Ohio. Hi, I'm Sharon. I'm from Utah, and I teach third grade math." I'm not going to keep on doing American voice. I'm not very good at it, but basically that for like 5 more minutes as they all introduce themselves.
Well, no. We didn't have multiple movies. Teach third grade math.
Yeah, I might be making up the third grade math. I think it was sixth grade math. They do what what they do is they do like they call it grade school, which is like grade 1 to like 5, and then you go to middle school, which is like grade 6 to 9, but they call it something different. And it's kind of like a mix between primary school and high school. So I think it's similar where they have like different teachers for different subjects. And then in high school they don't use numbers anymore. They call them like seniors and freshmen and sophomores, and it doesn't make sense to me. I don't know what the different things mean. I'm really excited for my junior year. It's like, cool, bro. Asking the spicy questions there.
Yeah. Then shoot anyone.
Jesus, they don't have to shoot people in America either. Okay, let's do this maths, guys. So -8 out the front, 8 squared is 64. 4 times 6 is 24. 24? Yeah, and then it's minus, so it becomes plus 24 over 12. So that becomes -8 plus or minus 88 over 12. Now, it would have been nice if I made that so that it was around, so it actually was a non-decimal answer, but I didn't, because apparently I'm mean. I'm going to treat this like it is tech active and use my calculator. Because we can't, the reason I'm doing this, by the way, guys, is you can't solve the square root of 88 in your head. So I don't expect you to. If I only asked you for the x coordinates, you could leave that and just answer -8 minus root 88 over 12 and -8 plus root 88 over 12. But because we've been asked to solve, we're going to have to solve. So that's 2 times a on the bottom. Plus the square root of 88 divided by 12 is 0.12, roughly. And my other point, -1.45. So, are we done? No. What do we got to do? Yeah, we've got to find the actual turning point locations. Because we have the x part of their locations, but we don't know the y's. So what I'm going to do, can I get U3? Can you do the 0.12, sub it in? U3, can you do the -1.45? And then we'll come back together. So, yeah, into. So, solve for f of 0.12. You're on the negative side. And f of -1.45. So, f of 0. Yeah, you'll have to use your calculators for this one. I didn't make this one tech-free friendly, unfortunately. I'm just picturing when the camp students come back. I can hear it. Sky just like, sir, you have a lot of issues with Americans, don't you? So 2 times -1.45 cubed plus 4 -1.45 squared minus -1.45 plus 3. Does anyone have a y value yet? 2.14? 2.94. No, I just didn't hear if you said 1 or 9. I couldn't make it out. So 2.94? And negative group, do we have a height at negative 1.45? No.
What did you say you got?
I didn't say anything for this one. We got 2.94 for the first one. What do you... I was talking to Clarice. I don't know what you guys are on about. No, I said, negative guys, do you have one? And oh, I said, did you get an answer for negative 1.45? I didn't say, like, is your answer this? So what did you say it was, sorry? One more time? 7, 6. We'll round it off to 2. Cool. Have we got question 1, 2, 3 in your textbooks on page 652? 65 DOS.